Hello everyone, welcome back. So this particular exercise is the second exercise associated with our Introduction to Variables section. And in this case, we're just going to do some simple little calculations to provide an additional exposure to the concept of declaring variables in your VBA code and then using those variables for calculations. So the context of this is we have this little spreadsheet here that allows you to do some calculations associated with applying the brakes on your car. And the scenario is you're driving down the road and you spot something in the road. And the question is how long or rather how far, what distance do you travel between the time you spot something in the road and you put your foot on the brake? And that is a function of something that we're calling the reaction time. And so the way this is set up is we have three option controls here, that one for slow, one for average, and one for fast. And if you're slow, it takes 1.1 seconds to put your foot on the brake. If you're average, it's 0.7 seconds, and if you're fast, you can do it as quickly as 0.4 seconds. And so the user is going to click on one of these buttons to select a reaction time, and that number will be echoed to this cell B12. And then once that's entered, you also input a driving speed in miles per hour. And then click on the compute delay button, and at that point we're going to read the reaction time from cell B12, the driving speed from cell B13, and we are going to then do some calculations to determine how many feet you would travel during that delay time, and we're going to write that result to cell B14. Now the calculations that we're going to put here in reading from cells B12 and B13 and then putting the answer in B14, we could do that using an Excel formula, but again, the objective here is to get a little bit more practice using variables, and so we're going to do these calculations in Visual Basic using variables. So step number one, write code for each of the option controls that sets the reaction time cell appropriately. Now, by the way, these cells are named. So this one is called reaction time, and this one is called speed, and this one B14 is called delay. So we've named the cells, and that is done using the naming process for cells, which is covered in a different chapter of the Excel VBA primer. And again, the assumption here is that you've read the variables chapter in the Excel VBA primer and are familiar with variables in general, and hopefully you've completed the variables exercise part 1, where we introduce the basic concepts associated with using variables. So that we're going to go a little bit faster on this one, maybe not provide quite as much explanation, because we assume at this point that you're kind of basically familiar with how variables work. All right, so part 1, we're going to link these options to this cell B12, and this is kind of a review of our discussion on controls. It has nothing to do with variables, but it's repetition helps us learn all of these different concepts. So I'm going to go into design mode up here in the developer tab, and I'm going to double click on this control. It pops us over here, and then I'm going to say range, and let's use the cell name. So we could put range B12 equals 1.1, but we can also reference that cell using its name. So in the range object, you can either put the default name, which is B12, or its custom name, which is reaction time, and we're going to set that equal to 1.1, and then pop back to Excel. And now I'm going to go down here. I'm going to select that line and copy it to the clipboard because I'm kind of lazy. and we'll change that to 0.7. And then finally I'm going to double click on fast, Control V, copy that from the clipboard, and now we have the code written for the click event for each of these three option controls. And we can save our changes, exit design mode, and now you can see those controls are then linked to this cell right here, and whatever we select there is echoed to that cell. So now we're ready to go to the next step, which is to read these numbers into variables, do some calculations, and just put the results back here in cell B14, which is also called delay. So let's go into design mode, and we'll double click on that button. And as we learned last time, we can save ourselves a lot of heartache by typing option explicit at the top of our code before we start using any variables. And this forces us to declare our variables. So we're going to say dim, let's see, we have, I'm going to call this R time as double for the reaction time. And we're going to have one called speed for the speed. And let's call the third one distant, DIST for distance, and that should get us started. So first of all, we're going to read the reaction times. We're going to say R time equals range, and again we can use the cell name to reference that, and then we can say speed equals range speed. So what we're doing here with these two assignment statements is we're simply taking the values from the cells and copying them into the variables so that we can use these variables in our calculations. Now you could say, or you could argue, well, why not just reference range reaction time and range speed in your expressions and your calculations? Well, you could. Sometimes it's a little simpler and cleaner to first copy those values into variables and then do your calculations based on the variables. And again, our exercise here is to learn how to use variables, so we're going to do it that way. So now we're ready to calculate the distance, and of course the distance, well, first of all, before we do the calculations, we need to remember that the speed is entered in miles per hour, and we need to get our final result in feet, and our reaction time is in seconds. So in order to do our calculation of velocity times time, before we do that, we need to convert our speed to the proper units. We need to convert from miles per hour to feet per second, and there's a simple way to do that. We're going to type speed equals speed times so it's in miles per hour, and 1 mile is equal to 5,280 feet. So we're going to say times 5,280, and then we're going to convert from per hour to per feet, we're going to divide by 3,600, which is 60 times 60. There are 3,600 seconds per hour, and that should convert from the speed from miles per hour to feet per second. Now, something you need to really pay attention to here. Notice that we have speed on both sides of this expression. Now remember what we discussed last time. An assignment statement is different from a statement of equality. We're not saying, 1 equals 2. We're not saying both sides of this statement are equivalent. We're doing an assignment statement, which literally should be interpreted as take the value resulting from the expression on the right and store it in the variable on the left. So what's on the right, but when you're first learning to program, it might seem kind of odd to see the speed on both sides of the equal sign in a statement like this. But we do this all the time in programming, and it works out fine. So what we're really saying is take the current value of the speed variable, the current value that's stored in the speed variable, multiply it by 5,280, and then divide it by 3,600, and then this entire expression will return a new value which you would then store in speed. So it's very common to have a variable name on both sides of the expression. Another one that we use a lot is something like this: x equals x plus 1. In programming, that's a very common way to do what's called incrementing a variable. So we say take the current value of x, add 1 to it, and that's the new value of x. It's kind of what we're doing here. We're saying take the current value of speed, convert it from miles per hour to feet per second, and then store that in speed. Okay? All right, now we're ready to do our calculations. The distance is equal to the speed times the r for reaction time. And then at this point, we are ready. We've done all of our calculations. We can tighten that up a little bit. You can format, in terms of spacing out your lines of code, you can do whatever whatever looks good to you. It doesn't matter if you have extra empty lines in there. It's just a matter of how you want it formatted. And the only thing left now is to take the distance that we've calculated and throw that, store that into the cell. And to do that, we're going to use one last assignment statement. And in this case, we're going to say range delay. Pretty sure that's what we called it. Equals dist. So this, take the value of distance and store it in the cell that is called delay. And that should work. Let's go try this out now. And we'll exit design mode and compute delay. So there we are. If you have a fast reaction time, you're driving 45 miles an hour. You'll travel 26 feet before you put your foot on the brake. And let's try this one: 46 feet, 72 feet. Now let's suppose we're going a little faster. There are certain roads in the state where I live where you can drive 85 miles an hour. Let's see how far you travel there. So 49 feet, 87 feet, and 137 feet you would travel before you even put on the brakes if you're going 85 miles an hour. So anyway, that wraps up this particular exercise. Gave us a little more practice using variables, and hopefully this is starting to become second nature to you.